Okay, so a circle is shown with both an inscribed and a circumscribed square. Find the ratio of the inner square to the outer square. So it kind of starts off similar enough to the last question. So we have to find the area of each square. So I know the distance from the center of the circle to the edge of the circle is r. If I continue that out here, well, because this is a square, I know that diagonals of a square are going to cross each other at 90-degree angles, or perpendicular angles. So I know that's 90 degrees. I know that's r, and I know this length here would be the hypotenuse of that triangle. So let's work out what that side is. So the hypotenuse squared is equal to r squared plus r squared. So h is equal to the square root of 2r squared. So that's length of one side, root 2r squared. So it's a square, so every side is length root 2r squared. So this side is root 2r squared. So the area of that is equal to root 2r squared multiplied by root 2r squared, which is area is just going to give me 2r squared. So that's the area of my small square. Now the area of the large square is even easier. So obviously the distance from the center of my circle to the edge of my circle is r, and the distance from the center of my circle to the edge of my circle is r. So the length of this is 2r. It's a square, so there must be 2r on the bottom as well. So the area for the big square is just 2r by 2r, which is 4r squared. So if we look at a ratio of the inner square to the outer to the area of the outer square, the ratio is 2r squared is to 4r squared. Now we simplify it the same way we simplify fractions. R squared can be taken off both sides. Both sides can be divided by 2. So if I divide the left by 2r squared, I get 1. If I divide the right by 2r squared, I get 2. So the ratio is 1:2. Alright, part 2 of question 8. An equilateral triangle is shown with both an inscribed and a circumscribed square. Calculate the ratio of the area of the circumcircle to the incircle. So let's look at the circumcircle first, sure, for the outside one. So we know the distance from here to here is obviously r. So I'm looking for the ratio of the area of the outside circle to the inner circle. Okay, so let's call that R1, so the outside circle. So the area of the outside circle area is equal to pi times R1 to be squared.